There are two common air quality concerns in aquatics facilities: chloramines and condensation. The issue of chloramines is the most common air quality concern in aquatics facilities, and it stems from using chlorine to treat pool water. Chlorine disinfects water in order to protect the health of swimmers, but when it combines with organic pollutants in the water, like sweat and body oils, for example, chloramines are formed. It's the chloramines, not chlorine, that are responsible for the well-known pool smell. Even more concerning than the smell is the fact that chloramines can pose health risks as they build up and become airborne. Symptoms of overexposure to chloramines include irritated eyes, nose, mouth, and lungs, discomfort that many swimmers are familiar with. The second facility management concern for aquatics facilities is condensation. Indoor moisture levels are extremely high around pools, making interior surfaces highly susceptible to condensation. Both of these concerns show why optimized airflow is critical in aquatics facilities. Good air quality is important to both swimmers and spectators, and it's also a national concern. In 2014, the U.S. Department of Health and Human Services Center for Disease Control and Prevention released its Model Aquatic Health Code. In Section 4.0, the code lays out many air handling system requirements for aquatic centers. High-volume, low-speed fans help achieve these requirements by accelerating the air turnover rate by thoroughly mixing the air. There are 3 Model Aquatic Health Code directives that the HVLS fans help facility operators to accomplish. The first is condensation prevention. Aquatic centers are often humid. They have a high dew point, meaning that there is a high concentration of water vapor in the air. If this air, heavy laden with water vapor, meets a cooler surface, it will deposit the moisture on that object, creating condensation. Facilities with prolonged condensation issues will experience biological growth and corrosion of their building materials. HVLS fans offset humidity by homogenizing the air, thereby equalizing the temperature, minimizing moisture deposits, and speeding up the drying process. The second directive HVLS fans support is consistent airflow. Stagnant air is problematic for 3 reasons. First, aquatic centers have building requirements for the amount of time it takes to turn over all the air in the space. If there are stagnant areas, this requirement is not being met, and the conditions this air turnover is meant to remediate are still there. Second, inadequate air circulation makes swimmers and spectators uncomfortable. And third, stagnant air promotes condensation buildup. HVLS fans eliminate stagnant air by delivering consistent airflow throughout the facility and by accelerating the air turnover rate. The third Model Aquatic Health Code directive that HVLS fans help accomplish is maintaining airflow across the water surface. As we mentioned earlier, after chlorine combines with the organic pollutants in the pool, it becomes a chloramine. Chloramines are 4 times heavier than standard air, so the chloramines tend to hover over the water. So how do you pull something so heavy up and out through an exhaust system? The solution is to increase airflow across the pool surface. In summary, HVLS fans promote healthy aquatic environments by completely circulating the air in the facility. Thoroughly mixing the air equalizes the temperature, minimizes moisture deposits, and speeds up the drying process. HVLS fans deliver large volumes of air at adjustable speeds to propel the plume of chloramines up to the exhaust system.